Hello everyone and welcome back to the next lecture of control systems. In this presentation, we are going to have the review of Laplace transform part 2. In the part 1 of this lecture, we discussed the introduction of Laplace transform. We had the expression to find out the Laplace domain of any time domain function. And at the end, we also discussed the Laplace transforms of some standard signals. Now in this part, we will discuss the properties of Laplace transform. So let's get started. The properties of Laplace transform play a very important role whenever we find out the Laplace domains of different time domain functions. We will discuss the importance of these properties with the examples. I will give you the property and we will discuss one example based on that property. I will not give you the proofs of these properties, so if you want to refer the proofs of these properties, you can refer them from the Signals and Systems course. So let's start with the first property, which is the linearity property. The linearity property is a combination of two different principles. One is the homogeneity principle and the other is the superposition principle. So if f1 of t is a time domain function which has a Laplace domain f1 of s, and f2 of t is another time domain function which has a Laplace domain f2 of s, then according to linearity property, a multiplied f1 of t plus b multiplied f2 of t has a Laplace transform of a multiplied f1 of s plus b multiplied f2 of s. Now we will discuss that how this property is a combination of homogeneity and the superposition principle. So if f1 of t has a Laplace transform of f1 of s, and if we multiply f1 of t with a constant a, then its Laplace transform f1 of s will also be multiplied with the same constant a. Similarly, if we multiply f2 of t with a constant b, then its Laplace transform will also be multiplied with the same constant b. This is the homogeneity principle, that if we multiply a constant in the time domain, the same constant will be multiplied in the Laplace domain. Now, according to the superposition principle, if we add these two functions in this way, their Laplace transform will also be added in the same way. So combining the homogeneity principle and the superposition principle, if we multiply some constants in the time domain and add these two functions, their Laplace transforms will also be multiplied with the same constants and will be added in the same way. Let us take one example to understand the linearity property in a better manner, and the example is given as: find the Laplace transform of the following function. F of t is equal to ut plus 2 multiplied e to the power minus 3t plus 3 multiplied sine 2t. Now we can understand the importance of Laplace transform properties. In this case, we don't have to find out the Laplace transform of f of t by substituting this function in that complicated expression that we have discussed in the previous lecture. If we have the Laplace transform of these three functions ut, e to the power minus 3t and sine 2t, we can easily find out the Laplace transform of f of t by using the linearity property. And we have the Laplace transform of these three functions. We discussed one table in which we had these three functions. So what is the Laplace transform of ut? Yes, it is 1 upon s. And what is the Laplace transform of e to the power minus 3t? Or we can say, what is the Laplace transform of e to the power minus at? It is 1 over s plus a. And what is the Laplace transform of sine omega t? It is omega over s square plus omega square. So now we will apply the Laplace transforms to these three functions, and by linearity property, we can easily calculate the Laplace transform of this function. So moving on to the solution, we can write f of s is equal to the Laplace transform of this function, which is equal to 1 over s. Now, the Laplace transform of e to the power minus 3t will be 1 over s plus 3, because a is replaced with 3 in this case, and it is multiplied with 2, then by homogeneity property, we will have 2 multiplied with 1 over s plus 3. And similarly, the Laplace transform of sine 2t will be 2 over s square plus 2 square, and it is multiplied with 3, so we will have 3 multiplied with 2 over s square plus 2 square. Now we can rearrange this and we can write it like this: f of s is equal to 1 over s plus 2 over s plus 3 plus 3 multiplied by 2 is 6 and 2 square is 4. So it will be 6 over s square plus 4. So this is the Laplace transform of f of t, and we have calculated this by using the linearity property. So now we are done with the linearity property, and now we will move on to the next property, which is the time scaling property. Firstly, we will understand the meaning of the word scaling. Suppose f of t is a time domain function which is having the Laplace transform f of s. Now if I multiply a constant to the argument of this particular function, then we can say that we are scaling this function. So the Laplace transform of f of at, which is the time scaled version of f of t, is given as 1 over mod a f of s over a, where f of s is the Laplace transform of f of t. So we can see that we need to substitute s over a whenever we have s in the Laplace domain. Let's understand this property with the help of an example. If the Laplace transform of f of t is 1 over s plus 1, then find out the Laplace transform of f of 2t. Now this function here is scaled with the factor 2, where f of t is having the Laplace transform 1 over s plus 1. So we have the Laplace transform of f of t as 1 over s plus 1, and we need to find out the Laplace transform of f of 2t. So we will use the time scaling property to find out the Laplace transform of f of 2t, and we can write it as Laplace transform of f of 2t is equal to 1 over mod 2, because the value of a here is 2, f of s over 2. Now we need to substitute s by s over 2 in the Laplace transform of f of t. So we can have 1 over 2, because 2 is a positive number, so mod of 2 will be 1 over 2, and the Laplace transform of f of t is 1 over s plus 1, and we need to substitute s by s over 2, so we have 1 over s over 2 plus 1. We will take the LCM and 2 will be cancelled, and we will have 1 over s plus 2. So the Laplace transform of the time scaled function f of 2t is 1 over s plus 2. So now we are done with our discussion on the linearity property and the time scaling property. We will discuss some more properties in the next lecture. I'll end this lecture here. See you in the next one.